students, let's study the basic proportionality theorem from this similarity. Basic proportionality theorem, it is also called as a BPD. It is a shortcut. We can use the BPD also. Now in this theorem, it says that if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. Here in the theorem, they have said one triangle. So I'll consider here there is one triangle A, B, C. In this triangle, they said that the one line is a parallel to the third side, and it intersects these AB and AC in the point P and Q, and it's a proportion. Means what is given? Given that line PQ is parallel to third side, that is parallel to BC, and it divides the remaining two sides in the two distinct points. So which points? P and Q points. So here they have said to prove these whatever the sections these line parallel to third side and it divides and it's in proportion. Means here we have to prove that AP, this part AP upon PB is equal to AQ upon QC. So AP upon PB is equal to AQ upon QC. So these things we have to prove it. So to prove this theorem, I have to do some construction. So next part comes construction. In this construction, I am going to join PC and QB. So join or draw PC and QB. Students, if you observe, if I join the PC, I'll get a triangle APC. If I join the QB, I'll get another triangle AQB. Okay, and then APQ. That means here I'll get three triangles. One, second, and here this one is a third one. So this theorem we can prove it in three steps. So here proof. To prove it, in the first step, I'll consider the APQ and triangle QPB. So in triangle APQ and triangle QPB, if you will take the ratios of the areas of these two triangles, area of a triangle APQ upon area of triangle QPB. If you observe, both of them, they have the same vertex, common vertex Q. And from common vertex Q, if I measure the height, then both the triangle will have the equal height. So these two triangles are having equal height. So if these two triangles are having equal height, that means their ratios are proportional to bases. So what is the proportion? AP, for this AP is a base. For this triangle PQPB is equal to PB is a base. If you want, then you can reverse the page and you can check it. What are the bases? AP and PB would be the bases. So this is the first statement. Similarly, I'll consider the first triangle and this third triangle. First triangle means again triangle APQ. In triangle APQ. And another triangle I'll consider PQC and triangle PQC. Again, if you observe, in these two triangles, I'll consider P is a common vertex, and from P I will draw the height. That means height is common for APQ and PQC. So if height is equal, then these ratios of areas will be proportional to their bases. So area of a APQ upon area of a PQC is equal to proportional to the base. What is the base of this? AQ upon QC. Second statement. Students, observe, I have taken the first triangle and second triangle. Then I got the first statement. Then first and third triangle. I got the second statement. After this, I'll consider the second and third triangle. That means A triangle BPQ and triangle PQC. These two triangles are lie between the two parallel sides. That means their height is same and they have the common base PQ. PQ is a common base. Just you check it. PQ, PQ. PQ is a common base. So therefore, the area of these two triangles BPQ is equal to area of a triangle PQC. So this is the third example. Therefore, from 1, 2 and third equation, if you observe these all three equations, so in first equation, second equation and in third equation, first equation the area of a APQ, here also second equation area of a APQ, mean numerators are same. Similarly, QPB and PQC, denominators, from these you can see the denominators are also same. So if numerators are same and denominators are same, that means of course these two area of a triangle APQ upon from 1 area of a triangle QPB is equal to, from second equation, area of a triangle APQ area of a triangle PQC. Numerators are same, denominators are also same, that means all these are equal. So if these are equal, that means AP upon PB is equal to AQ upon QC. Hence it is proved. Students, in basic proportionality theorem, we have seen the side, if line is parallel to the third side of a triangle, then the line divides those two remaining two sides in the proportion. So if we are going to see the converse of that Bpd theorem, so converse of Bpd, if line, now here this is a ABC triangle and this line is parallel. So AP upon A and P and B. What the Bpd theorem says? If line is parallel to this side, then we will get the ratio AP upon PB, AB upon BC. In converse of Bpd theorem, reverse the statement. If we have AP upon PB is equal to AB upon BC, therefore by converse of Bpd, we can say that line L is parallel to side BC. So this is the converse of Bpd. It is helpful to prove that the line is parallel to the third side. Students, what we have studied in this video, just we will revise it. First, Bpd theorem. In this theorem says that A, B, C, this is line L. So line P, Q. If line L is parallel to BC, then by Bpd theorem says that AP upon PB is equal to AQ upon QC. This is the Bpd theorem. Next we have studied the converse of Bpd. What is it? Converse of Bpd? It will help you to prove the line is parallel. Means if AP upon PB is equal to AQ upon QC, therefore line L is parallel to side BC by converse of Bpd. Thank you. If you like the video, please subscribe it.